No, I didn't. No, I bought them in a garage sale. All right, here we go. Eight point three, test for parallelograms. Up on the top, this is what, 22614. A lot of what we're doing is the same as what we did yesterday. You basically have tests for parallelogram. If the following or I'll say if one of the following is true, then the quadrilateral is a parallelogram. If the opposite sides are parallel. If the opposite sides are parallel, then it's a what? Parallelogram. Oh, thank you. If opposite sides are congruent, then it's a parallelogram. If the opposite angles are congruent, then guess what? It's a parallelogram. And I'm talking about both of them, not just one set. If the diagonals bisect each other, then guess what? It's a parallelogram. If put all consecutive angles are supplementary, then guess what? It's a parallelogram. If a diagonal separates the parallelogram into two congruent triangles, then guess what? Anybody?
It's a parallelogram.
It's a parallelogram.
Wouldn't that be if the diagonal separates the quadrilateral?
Okay, quadrilateral. Huh?
He said, damn, Mr. Stone.
Yes. Opposite sides are parallel. Now, here's all of these have been from the last section, haven't they? Just in opposite order, the converse of them. The new one, if a set of, let's say if one set of opposite sides are both parallel and congruent, then the quadrilateral is a parallelogram. So it's all the facts from the last section in converse, all the theorems basically saying if you prove that both opposite sides are parallel, then you know it's a what? Parallelogram. If you prove any of these, any of these 7, if you prove it true, then you know you've got a parallelogram in front of you. Okay? As you would imagine, we're going to apply those facts. Everybody got that down?
No, all of it. Not even if it's. Okay, so sure. What?
You don't have all of it down?
No, not all of it.
Then why aren't you writing?
There you go. I am right.
You're talking right now.
Oh, you can check it.
Okay. The directions here are determine whether each quadrilateral is a parallelogram. If yes or no, write yes or no. If yes, give a reason for your answer. Well, this is dealing with the angles, is it not? How do I know? Can I find out what that angle is?
Yes.
How, D?
By 112 is congruent to the other angle.
No, I didn't say it was a parallelogram.
What?
We're having to prove that it's a parallelogram. So how can I figure out what this last one is to see if it is a parallelogram? Does anybody know?
Oh, I did.
How?
Add them all up and subtract about 360.
Right. The angles inside of a quadrilateral must add to 360. So what's 68 and 68? Somebody, you have a calculator, don't you? 136 plus 112 would be what?
248.
What is 360 minus 248? Okay, that's the reason this is 112, not because it's a parallelogram. Now, because we can say that's 112 because of this. Is this a parallelogram?
Yes.
Yes, it is. And if we say yes, we're supposed to say why. Why?
Opposite angles are congruent.
That would be sufficient. This is what I'll expect on your papers. If you just write yes and you don't tell why, you might as well have not done it. Because if you can't write down why, you're copying or guessing. So that's not what I'm trying to get from you. On to number 2. Is this a parallelogram? Tell me why.
All
Opposite
sides
sides
are
are congruent. On opposite sides are
Hey.
parallel.
Turn around. Opposite sides are congruent. What?
so that
Tough. Now, how about this?
yes.
Why?
Diagonals bisect each other.
What are you doing?
I was trying to ask her something.
Diagonals bisect each other. Yes, diagonals bisect each other. What about this? Yeah, we can't prove those.
No, that's a
Well, actually, we can. Side angle side. Side angle side, so the two triangles are congruent. You could say because of that. However, you could also do this. Because the alternate interior angles are congruent.
SAS.
Hey, because the alternate interior angles are congruent, then you know that this is parallel to what? Okay? Do we have a theorem that says if you have one set of opposites, that's the new one, isn't it? If you have a set of opposite sides that are both what? Parallel and what? Congruent, then you know it's a what? So yes. One set of opposite sides are parallel and congruent. One set of opposite sides are parallel and congruent. The answer is yes. Number 5.
Yes.
Tell me why.
Opposite sides are congruent.
Why?
Why? Because that's congruent to that, and that's congruent to that.
Is there a theorem? Did I leave out a theorem? Is there a theorem in there that says this?
No.
Guess what, guys?
We can't see that.
These two sides pretty much look parallel, don't they? These two look congruent, don't they? Is that a parallelogram?
No.
So there is no theorem that says this, right? So what's the answer?
Nope.
It has to be the same set of sides that are what? Congruent and parallel. How about here?
Yes. All
Why?
sides are congruent.
Opposite angles are congruent. I'll have that, coach.
Y'all on number 6?
Yes, sir. I got it. I'm sure.
Let me see it. Let me see number 6. See what you've got written down.
Oh, I don't have nothing down for that, but I got.
So you just lied to me.
No, I just told you. I just wrote that on the phone.
You said I have that. I was talking about this
Ah, see, I can know you something like that.
because you're not listening. Now, Number 7. I have alternate interior angles congruent, so this is parallel to this.
And then those two. That's our new theorem.
No, it's not. See, I can't prove that these two triangles are congruent either by the information given. Can I? I have side-side angle. Correct? So, can I say this is a parallelogram?
Nope.
By here.
Yes.
Opposite sides are congruent, so, yes, because opposite sides are congruent.